welcome. My name is Spencer Gibb. I am the co-founder of Spring Cloud and lead the Spring Cloud core team. Today we're going to talk about Spring Cloud Gateway in Loom or Spring Cloud Gateway in VC. Yes, I'll show this for just a second. So we're going to talk a little today about basic API gateway terminology and discuss a little bit about that to get a baseline understanding of what they are. Then we're going to go through our trilogy. We're going to talk about Zuul, the original Spring Cloud Gateway, and then issue 36. We're going to talk about how what the new functionality in Spring Cloud Gateway looks like, and we'll do some demos and maybe some questions at the end. All right, so what is an API gateway? And what's it for? What's it do? What are the basic flows through a gateway? So it's kind of the age-old question, how do I expose my services, right? So I have all these applications. There's some network, typically the internet. How do I get it to a browser? How do I get it to a mobile phone? And an API gateway is just the thing to do that, right? Or some kind of proxy, right? Like you get a request and it determines where it should go. And this is what a request lifecycle looks like in lots of different gateways. You get a basic HTTP request, and there's something that says, hey, this is the right place for me, so it matches a predicate. There are some optional before filters. It goes to the application processes the request. There's optional after filters. Those from the Zuul world may know those as pre or post filters, and then we get a nice response back. So let's start with Zuul. Not the Ghostbusters character, but the original Netflix API gateway. So they built this when they were on straight EC2 and needed some functionality that AWS just didn't provide. And so when Dave Sire and I started Spring Cloud, we brought this in as part of Spring Cloud Netflix. It's exposed as a servlet or a servlet filter. You can kind of pick. I think we did the servlet. So this is a thread per request model, right? Basically like all servlets have been for a very long time. There are most of the filters that users cared about were pre and post, but there's also route filters. This is the thing that actually made the request downstream. And then in the case of error, there was an error filter type. Very, very simple. Basically, each of those types was give me a list of all the filters. And if it's type pre, do a for loop. So it's very simple. And it didn't come with any filters. It was just this basic framework. And so we went about building all these filters. So this was our API gateway number one. Super awkward API. There were a lot of, for example, you have to return an object from a filter, but it's never used. It's like they built it in, maybe in the case that some future version we might need it. There was also a lot of static variables and things all over the code base, and so it was an awkward fit in Spring as well. There was basically built in only a path predicate. So you couldn't match on anything else unless you did it all by hand. So then a while ago, Netflix announced they were going to do version 2 of Zuul. They wrote a blog post and they spit out a snapshot of the code. I was attending a conference as an attendee in Boulder, Colorado, and was thinking about it since I didn't have to speak. And as I was looking through the code, having already integrated it once before, I was like, oh, this is going to be such a pain to reinvent the wheel and do things. So decided to, this was right at the same time as Spring Framework 5, Spring Boot 2 were coming out. Spring Framework 5 introduced WebFlux, which was based on Project Reactor. And I decided, well, maybe we could reuse some of these things. And I didn't have to build everything from scratch, and we could get a better developer experience with Spring Cloud Gateway than we did with Zuul. So I wrote up a small doc and did a proof of concept, and sure enough, it worked. And everyone was like, yeah, let's do it. Let's not integrate Zuul 2, but let's build our own thing. So it's a sibling to basically @controller in WebFlux. We have a handler interceptor, or excuse me, anyway, the plumbing there that matches. When I built it, we built config first. So from the config file, route configuration, and then later we added a Java DSL. So the developer experience is much better. There are all the filters and predicates are scoped to a single route. The APIs for building those are fairly simple, so it provided a much better developer experience than Zuul did. Because it's built on WebFlux and Reactor Netty, you get this non-blocking event loop style architecture, which for an API gateway is ideal, right? Because you're just streaming data back and forth. You're not actually doing a lot of processing on that data. Flexible routing. So Zuul only had path predicates, and so we went, let's open it up. Basically anything in the request you can match on, so which is a very, very nice experience and allowed for much more flexible routing. So some things are pretty complex just because of the nature of Project Reactor and reactive programming. And it currently requires Netty server. Hopefully working on it so you can use Tomcat and Jetty, but it will still be WebFlux, this version of Spring Cloud Gateway. I'm calling it Spring Cloud Gateway Reactive, or Reactive Spring Cloud Gateway, kind of in my mind now. So issue 36. So one of the oldest issues, I created it because I knew we were going to lose this from Zuul, right? The ability to run a gateway and then servlet or Spring MVC implementation. More votes than any other Spring Cloud issue I'd ever seen. But for a long time, it just kind of didn't make sense. But then Project Loom or virtual threads have been on the radar for a little while, and then things started progressing, and there was things started progressing, and eventually it was going to be part of JDK 21, part of Java 21, Loom and virtual threads. There's a great talk from Spring 1 at Explorer later this year, earlier this year, that you can go watch to get some good information about Loom. So what is Loom? Loom is virtual threads, lightweight threads. The prior to Java 21, the thread implementation was a fairly heavyweight one-to-one mapping of threads to operating system threads. There was a lot of memory overhead. So virtual threads are lightweight. They reuse OS threads, so for every virtual thread, you don't have to create a new operating system thread. It was preview in previous JDKs, and I need to update this slide, but it happened already. Java 21 is out, and it graduated, so now we have virtual threads. And the support for virtual threads is ongoing and will be released in Spring Framework 6.1 and Spring Boot 3.2. So let's build this thing then. With all this momentum, let's go ahead and do the Spring MVC servlet implementation. So kind of a quick demo here. Basically what I want to show is how you, well, first of all, that we're using Spring Boot 3.2.0-M3 and Spring Cloud 2023.0.0-M2. And then to enable, and then Spring Boot Starter Web, right? So for just a basic Spring Boot application, that's all you need. But we're adding this new starter from Spring Cloud Gateway, MVC. To enable virtual thread, it's still opt-in, and that's all you do. Spring.threads.virtual.enabled equals true. And that's what gets us virtual threads enabled. And that's all I have to do. I didn't do anything specific in this implementation for virtual threads. It's currently all handled by either kind of going down the stack, either by Spring Boot, Spring Framework, and then even below that, like Tomcat, the servlet engine itself has to support this. And so there's some work that was done all the way up the stack to the point where the MVC gateway doesn't need to do anything really specific for virtual threads. So let's build this. So this is our third try, third time's a charm, right? So I have experience of building 2 other API gateway implementations. And so I have that experience. And so hopefully some of the things I've learned, I can take and do things differently or better in this new implementation. By the way, the reactive version is not going away. This basically will mirror Spring Framework, right? So they have WebFlux and Spring MVC. And they live side by side. One is reactive, one is servlet. And so same thing with gateway. We'll have reactive gateway server and MVC gateway server. So, but this new one is not WebFlux, so that should hopefully simplify things. So with the reactive gateway, we were using the plumbing. Basically, we're using these kind of big features in Framework, and in the MVC version, I wanted to use the porcelain, right? I wanted to use the more user-facing APIs and try not to implement as much as I needed to for the WebFlux version. Hopefully, we'll get more reuse out of the framework, make it even more user-friendly. So in Spring Framework, there is Spring Web MVC, and kind of a sub-package of sub-project of Web MVC is WebMVC.fn. So as opposed to the annotation-driven model of controllers, you have a functional version. So what we're looking at right here is a router function, and there's a DSL that you use, and in this case, here's the request predicate. It's 2 things. It's the HTTP method get and this particular path matching on any ID. You also pass to it a handler function, which is kind of mocked out below here. All it needs is a function that takes a server request and returns a server response. Then you can add optional filters to that router function. So that is a basic WebMVC application. So I wanted to show what that looks like. So here we have that. Here in this particular case, I just use a Lambda to create server response. You can also have some other method that you can reference. So I'm going to start this application. One thing I am going to use is the new test infrastructure for test containers. So I have this configuration with HTTP bin, and so this runs HTTP bin as a container for me. So I'm using the new Spring Boot functionality to run that. So let's go ahead and run that guy. So there you can see the test container starting up. Now if I come back here, my terminal, run that, and see hello world and hi. Right, so this application I'm using on the command line HTTP. If you learn nothing today, learn about HTTPie, the CLI version. I call it curl for humans. So there's your tip for the day. All right, so WebMVC.fn has an existing Java DSL. And it already has request predicates already built, matching, like I showed on that particular one, get. There's for every HTTP method. There's paths, and you saw that those can be combined. There's a header predicate, and then you can use Boolean logic and or not. In the demo I showed here, this is get and path hello, right? So they're already built in like that. And then you can, of course, write custom predicates. And then the filter API is really nice. There's a filter API, and then there's also the concept of before and after filters. Basically, if your filter only needs the request, it can be a before filter, and if it only needs the response, it could be an after filter. So I've taken advantage of this and made it some filters explicitly before and after, or pre and post, as in the Zuul parlance. In Spring Cloud Gateway, there's basically just a filter, and the way it works is if you did something before the filter chain, it was a before, and then after the filter chain, but there wasn't anything specific for those. Another interesting thing that it does is nested routes, which has been a request for a long time in the reactive gateway. Basically, if you have a large number of routes, hundreds or thousands, and many of them share a common path, you can nest them, so it basically looks more like a tree, and you can there's more efficient matching of these many routes. So there were some things that while I was building this that I wanted to do, again, based on past experience. I wanted to be explicit versus implicit, and you'll see a little bit of that when we start to get into the demos. But with the reactive gateway, there are a bunch of filters that are always there, and unless you either read the docs really close or look at the code, you might not know when or why they might apply. There's a bunch of beans that are factories for predicates and filters. So there's a lot going under the hood that you might know about. In this version, I wanted to be very explicit, so you see everything that's going on, and you can control it more finely than you can with the WebFlux version. Another difference between the WebFlux one and this, I wanted to be DSL first and build on top of the existing WebMVC.fn DSL, and then hopefully compatible with a similar configuration as WebFlux, but that would come second, DSL first. So flip the script on those. Trying to increase simplicity in this version. Some of that is just the nature of MVC versus Reactor, and so that's some of it, but also in the way that APIs are presented to the developers. So some of the goals, some of the things I wanted to use is the new REST client in Spring Framework. So this is the code that is, this is the object that is making HTTP requests. I also wanted that to use the new GADK HTTP client, which is also new in Spring Framework 6.1. Both of these are new and in Framework 6.1 and auto-configured in Spring Boot 3.2. Though the JDK HTTP client is not the default. If you just use normal Spring Boot web application, but it is the default if you do the Gateway MVC. So, of course, all these other clients underneath the REST client are also supported, but some of them have some issues with certain HTTP methods that they don't support. So I wanted to use the new one. New is always fun. So what are some of the use cases? Some places have organizational requirements, right? They need to use Tomcat. They need to use MVC. So servlet only. Another use case that we'd lost with Zuul is the ability to have an existing MVC app to be able to embed this, and then you can eliminate some of the problems that you have with applications existing across multiple URLs, right? You eliminate the CORS problem. And again, simplicity. Some people just wanted to wait until there was something as simple as Zuul. So some non-goals, 100% feature parity with the reactive gateway. It's pretty close, but there will be edge cases and some things that just don't make sense. There are some implementations that are different. For example, retry we use from Reactor, and it has very specific things that it can be configured. And in the MVC version, we use Spring retry. So that's just different there, things like that. Not immediately looking at performance parity. I haven't done any performance testing at all on this. Anyway, we'll leave it at that, but I suspect at some point we'll have some kind of numbers to show, or at least relative performance between MVC and reactive gateway. But anything you do there, it's anyway, there'll be pitfalls to all the different performance comparisons there. So what does this look like? This is part of the 2023.0 Spring Cloud release train. We GA in a month or so, soon after Spring Framework 6.1 and Spring Boot 3.2. Spring Boot 3.2 is currently scheduled for Thanksgiving weekend in November in the US. And we'll go either the week or two after that. Currently, the M2 is available. And if all things go well, next week we'll have an RC. So what remains? I have to write a bunch of documentation and some more advanced handler functions and filters. So how do we start? Well, initializer. It's a little old, so these numbers are updated. But basically, you need to add, if you want to get this from initializer, you need gateway and Spring Web, and that will get you the right gateway starter. So now it is demo time. So again, glancing quickly at the POM, Spring Boot 3.2.0-M3, Spring Cloud 2023.0.0-M2. Some of the things that here are those starters that I showed on initializer, Spring Boot Starter Web, and Spring Cloud Starter Gateway MVC. Some other things that we'll show in some of these future dependencies. We'll talk a little bit about load balancer. I'll talk about what Bucket4j does, circuit breaker, and retry. All right, let's get going. And I've already started the application. I showed you using the new test containers, bits. All right, so let's go to our first route. So here you can see that I've created a route using a static method. So typically, you would use this class from Spring Framework, router functions. And this is the entry point with a route method that returns a builder. In my case here, we have a gateway router functions. This thing just wraps the router functions call with a specific function in the route ID. I'll tell you about what that's for in a minute. So you could unwrap that, but so here we're saying get path, and this path / anything is part of HTTP bin. And so in our MVC application, we had either a Lambda or some method reference for the handler function. And in this case, we have this new method from Gateway MVC handler functions class called HTTP. Basically, we're saying this is explicitly going to do the routing for us. The handler function is the routing function. You can also pass a URI if you want to be explicit. But that this function needs to know where to go. And if it doesn't have a URL here, we need to supply it one. So we need some kind of filter that supplies the proper place for Gateway to go. For a lot of these demos, I'm just going to use, excuse me, this class HTTP bin URI resolver. I'm not going to go into it much, but basically, when we set up HTTP bin, we add some properties to the Spring environment. And then this class basically takes those out of the environment and creates a URI that this handler, HTTP handler function, can find and will route to. So let's go ahead and try this guy, so I know we're not lying. Oh, I didn't copy. All right, and so with HTTP, you get this beautiful color-coded and formatted output, so you can see what's going on here. These are the headers that were passed to the application, and you can see that the URL was anything /first. All right, so that's our first route. Let's go to second. So here we are going to kind of unravel that first route. So here, instead of using get, we're using the route method on the builder. And this allows us to do our Boolean logic, right? In this case, we're doing the same thing as before, just more explicitly get and path anything second. There you go. So this allows us to do much more complex routing here. So those are fairly basic routes. Let's get into another predicate. So here we start again our DSL. Again, we use the route method. Now we're going to use header. Again, we're using a gateway request predicates class. And it can be either just a header or a regex. So let's see what that looks like. So to pass a header, you just : separate a name value in HTTP. Here we go. So it's trying to match b.r. So if I say baz, I'm going to get 404. I do bar, and we get routed to the get method in HTTP bin. Okay, so a little more complex predicate. So here's another one. We get a little more complex again. We use the no new host predicate. And in this case, you can see we're doing ***. So that means anything under .myhost.org. Go ahead and show that. And again, we're going to the get method of HTTP bin. And you can see that you're looking at some of the things that Gateway does by adding trying to be a nice proxy and adding some things to the headers. But so the host we matched at myhost.org. Okay. So now we get a little more fancy, and we talked about this before, a nested predicate. So right off the builder is a nest method. Basically, you give it a path. So in this case, anything nested, and then you create routes like you did before. The other thing we're showing here is the ability to create multiple routes at once by using the AND method. So here we're creating 2 routes under /anything nested. We have nested 1 and nested 2. So if I try one of these, we went into nested 1 and of course nested 2. This is really handy, again, when you have, if you had several hundred paths but maybe only a dozen or so under any particular subpath, you could nest them and it would be really nice. All right, so now a little more advanced predicate. In this case, we're going to read the body of the request. I'll make a warning here that once you start to do reading or modifying the body, you kind of lost the streaming bits and now you're memory constrained. But lots of people use it. It's fairly common. And one of the nice things about this is when I was building it, I was like, this is going to be one of the last things I do, because I spent many, many hours with folks from the framework and reactor teams trying to get these types of functions to work in the reactive gateway, and I didn't need anybody's help, and it was actually fairly straightforward for me to do this in this new MVC gateway. So again, there's our HTTP handler method, HTTP bin, but like I said before, we wanted to be more explicit. And in the reactive gateway, if you do anything that reads or modifies the body, it reads it, but then it has to recreate it so that the body can be sent back out. And it automatically did this, but now it doesn't. And you need to tell it explicitly to recreate the body that was cached here to forward it on. So in this case, we're doing a post. And when you equals separate values here in HTTP, those are JSON, just turns it into JSON. So if we do this, then we get a match, and you can see the value that was sent, the data in as JSON. It was sent to the post method, and there's the red values back. So we matched this this predicate. All right, so now let's get into some filters. Now that we've covered a lot of predicates. All right, so in this case, we're getting /anything for add requests, HTTP bin, but in this case, we're going to add a request header. These values come from this class before filter functions. Show that up here. So these functions are those that only operate on a request. Okay. So each of them returns a function that takes a servlet request and returns a servlet request. So if you modify it, the return one is what is used. But these are also in the gateway filters class. We'll show you basically these are all adapted and can be used as regular filters as well. So add request header. This method is part of Spring Framework, and it adapts a before filter into a normal filter. All right, so back to our route function definition here. So we go ahead and run this. We should have, this was one of the headers sent to HTTP bin. Okay. Next is the set path filter. So here we are going to use the host predicate, but again, we reuse things that are provided in webmvc.fn. In the pattern matching, you can put braces around the parts that you want to capture, and then those get put into request attributes. So anything later in the request can use them. And most of the filters that act either on paths or headers or things like that have access to these values. And so in this case, we're just going to put that back out there. I run that, you'll see anything www. If I change that, again, that's updated here. So you can kind of make these dynamic. You don't have to be explicit about every single thing you do. It could also be in the path predicate. You can do that as well. So here we did add requests. This is going to be an add response header. And the reason this is interesting is because here you have a before filter. This is our first after filter. So another new file is after filter functions in Gateway MVC. And this particular one is add response header. Go ahead and run that. So now it's not going to be in any of this because this is what information was in the request. But here in the response, we have X after value. Okay. Here again is another after filter. This one is called set status. This one required some tricky work on my side because typically the status in Gateway MVC or in MVC.fn is read-only, and I had to work around that. /status is a HTTP bin method, and it will take whatever status is passed and just return that as the response status. But we're going to override that. So in this case, we're going to send a 5. The HTTP bin is going to respond with a 502, but we're going to set it to a 401. So we got back a 401, even though the actual status returned in the response was a 502. We overrode that. Okay. So here we start to get into some advanced filters. And I've I know I've got a little more time because things ended early, so I'm going to just keep going until my time's done. So this case, we're plugging into Spring Cloud Load Balancer, right? I showed that before. That was in our POM. Spring Cloud started Load Balancer. So here we're going to use that. So again, the normal route, get HTTP. But in this case, we have this LB method, which comes from the load balancer filter functions class. So basically what we're doing is this could be Eureka, this could be console, it could be Zookeeper, it could be properties file. In this case, I'm just kind of plugging in, and I'm going to say that we're going to use HTTP bin, but that's neither here nor there, right? This would be your whatever your company is using for, or your system is using for service registration and discovery. Let's go ahead and do that, just so we know that this URL can be dynamic from some external system. So it went ahead and forwarded to HTTP bin, plugging into the Spring Cloud Load Balancer. And you can see there's our request header that we added. All right. Next up is Bucket4j. So one of the things that the reactive gateway provided was rate limiting, and Stripe wrote about and provided some code that used Redis and a Lua script. Our commercial team used a different technology, but in this case, we used Bucket4j. So if I open up Bucket4j here in the browser, and then it's nice because it provides a bunch of distributed ways to, if you have multiple instances of a gateway, you need a distributed mechanism to so that all those instances know the same thing. And so you have a bunch of different things, anywhere from Hazelcast, InfiniSpan, Coherence, Redis, and JDBC. I am going to use a simple local cache since I don't need to start anything up. So back to here. Again, we're going to match on a path, HTTP to HTTP bin. And in this case, we're going to use rate limit from the Bucket4j filter functions class. And it has this kind of config class here, and I'll walk you through that. So we're going to say, if you want to read about the token bucket algorithm, it is fun. But basically, in this case, we're going to say you get one request every 5 seconds, but you need a key resolver. In this case, we're just going to do a static one, but this could be a header, like some kind of API key. It could be the principal from Spring Security that you match against some value. So this key resolver is important, but we're just going to use that. So go ahead and call this. You can see we get some remaining, because we only have one every 5 seconds, we're going to get 0. So again, it's been longer than that because I've been talking, but if I do it once and do it again very quickly, we get a 429, right? That too many requests. So this is gives some more flexibility in configuring the Bucket4j. Let's go ahead, and I want to do this one. I want to make sure I get it, but if we have time. So I don't have a route here. That is because you can define routes in the config file. So let's go ahead and look at that. So here we have Spring Cloud Gateway MVC. One of the new things that we've added is the ability to configure routes in a map as opposed to just a list. And the reason this is interesting Something I think we want to add to the reactive gateway is that from configuration sources, maps can be combined where a list cannot. So you could have some local routes defined, you could have routes in config server be defined, and they would all be here. So again, you can see here we're using the load balancer for the URI, our typical path predicate. So this is the shortcut configuration that we had in reactive gateway, and then the explicit configuration here in a filter. So we're going to add a request header, these values. And our route 2 is very similar, except just both shortcut. So if I go ahead and run these routes, you can see route 1, route 2 is there, but there should not be a route 3. We should get a 404. So if I come here, uncomment this guy, so you'll see I have the note force IntelliJ to build, so build project, because that puts this file from source main resources into the class path, right? And then one of the other things that was part of this was actuator. We've got, should be able to now do post actuator refresh. You'll see there's some properties that changed. And now I can come back to config route 3, and we have a new route, and I didn't restart gateway. That's a fun one to do. All right, so now there's that. We can, let's go up one to the retry filter. This one has a little more code because I have to simulate failures and then successes. So that's basically what I'm doing here, is that I am, rather than using HTTP bin, I'm getting this information about my local controller so that I can pass information in here so that sometimes it will fail and other times it will be okay. But we should see these logs in the server when we run this. Okay. So go ahead and run this. And the quotes around there are because of I use ZSH, and question mark will make things go crazy. So so if we come back to our running application and I search for retry count. So it tried once and failed, second failed again, and then the third time was a 200. Okay? So this is all using Spring retry. So here it is, Spring retry. We're going to retry 3 times. You can either just do that, or there's more extensive configuration, what statuses, what exceptions, etc. All right, one more. The circuit breaker. So if you're familiar with a circuit breaker, this prevents downstream failures from affecting clients. In this case, we are going to deliberately send this to somewhere that doesn't exist, right? Basically, we're creating failure. We're going to do, in this case, circuit breaker is a filter, not a before or after, because it does both. We're going to give it a fallback path. And that fallback path is also a route. And we're going to add this fallback headers filter. And you'll see what fallback headers does. So if I go ahead and run this, my terminal, you can see these are some of the things that you can then use in your fallback to determine to do something interesting. Here we say the root cause was an unresolved address exception, right, from this here. And here are a couple other bits of information that we send along as headers to that fallback. So then you could do whatever. And in our case, we just went to HTTP bin again, but you could do something custom here. It could be a local controller. It could be a different service, whatever. If we have time, I'll do my last demo as wait predicate. So weighted routing is, I don't have to, that's not a to-do anymore, but, well, maybe it is. So in this case, we're going to have two routes, and weighted is a predicate. So in this case, we're just going to do it 50-50, right? The math is done such that it totals up these values per group and then creates a percentage, and a new random number generator is used to determine if it was this one or this one. So when I run this, you should see a request header route 1 or route 2 roughly every other request. So there's route 2, route 1, route 2, roughly every other one. It's not guaranteed because it's a random number generator, but roughly it should end up like that. So this is useful for canarying or trying new features, things like that. All right, so that is it with the demos. Back to the presentation. All right. So probably the interesting thing here would be this URL, which is where the sample is. It's all updated. You should be able to get and run all those things on your own. And thanks for having me. I will now look into the chat, see if there's any questions that I can answer. Thanks for having me. Have a good rest of the conference.